Useful data is also given here. It simply means that some constants and the values are given. If you didn't remember any constant and you need for any questions to answer, you can come and you can find here. For AS level especially, you need to understand the value of G. The value of G you have to use in your exam, that is equal to 9.81 meters per second per second. You can also see some useful formulae also given here. This is formulae list. These are very common formulae. For example, you can look at the first one. This is what we need for AS level. I will just draw this rectangle around the formulae you need for AS level. This is also what you need for AS level. We don't need this one. This formula you also need for AS level here. Resistors in parallel, resistors in series you need for AS level. So these are the formulae you need for AS level. If you didn't remember them, you can come back and you can find them here. For AS level, you also need Doppler effect formula. Means Doppler effect equation you also need. If you look at this one at the bottom, you can see there is a plus and minus sign. So what's meaning of that? When to use plus and when to use minus? We need to understand if the source is approaching observed frequency, this one has to be greater than the source frequency, and this is true when the source is approaching. Source is approaching. So if the source is approaching, then you have to use the negative sign. Means the formula you have to write down, this will be Fs V over V minus Vs. So you have to use the negative sign here. When the source is moving away, then F observed has to be smaller than Fs, moving away. So we can write down when the source is moving away, then the formula you have to use F observed has to be equal to V over V plus Vs multiplied by the frequency of the source. Fs, S here is for source. So Fs is frequency of source, O for observed frequency, observed. So this is very important one you need to understand. First question is about reasonable estimate for the density of sand, and this type of questions are very common in this paper. Most of the time question 1 is about reasonable estimate. We need to understand how to approach this type of problem. The best way to approach this type of problems is comparison. Means you need to compare with something known, comparison with something you already know. So we can write down comparison with something known. That is the key concept you need to understand to answer this type of problems. For this question, we need to estimate density of sand. So the best way to estimate density of sand is density of water, and density of water is about 1 gram per cubic centimeter. Now next thing you need to understand, if we have, let's say this is a glass of water, and if we place sand inside this glass of water, sand will sink and finally sand will stay at the bottom of the glass. From here we can conclude density of sand is greater than density of water. This is greater than density of water. Next thing we need to understand the density of mercury. Density of mercury is about 13.6 grams per cubic centimeter. Now we need to understand the density of sand is much less than density of mercury. So we can simply estimate the density of sand can be around 2 to 3 times of the density of water, or simply we can say about 2 or 3 times. Even if you don't know it is 2 times, 3 times, 4 times, if you go through the options, you can find out the answer very easy. First of all, if you look at the first option, this is telling us density of sand is 200 times of density of water, so that is not possible option because the density of mercury is only 13.6 times. If you go to the second option, this is 2000, so this is telling us density of sand is 2000 times of density of water. That is also not possible. If we go to next one, this is 20 kg per cubic meter. So this is telling us the density of sand is 50 times less than density of water. So this is 50 times, or we can simply write down in a little different way. We can also write down like this. This is telling us this is 1 over 50 of the density of water. That is also not density of sand, because sand is denser than water. So this is not possible option. If we look at last option, this is telling us density of sand is about 2 times of density of water. So this is a reasonable estimate. So this is our answer. Question second is based on physical quantities and the units. For this question, we need to find out which physical quantity can have this unit. If you look at the first physical quantity, acceleration we can simply denote with letter A, and this is equal to force over mass. The unit of force is Newton and the unit of mass is kg. So it means this is not answer. So this is Newton per kg. So this is not possible answer. If we go to force, the unit of force is Newton and this is equal to kg meter per second square, kg meter per second square. So this is also not possible option. If we go to mass, for example, mass we can write down. Mass is equal to force over acceleration. So simply we can write down unit for force is Newton and the unit for acceleration is meter per second square. So this is meter per second square. So simply we can write down this is Newton second square per meter. This is correct answer. But if we look at momentum P, this is equal to mv, unit of mass is kg and the unit of velocity is meter per second. So this is also not possible answer. So the answer is C. For this question, a velocity vector is given. As you can see here, the magnitude of the velocity is 75 and the angle with vertical, this is equal to 30 degrees. The question is asking us about the components of the velocity vector in north direction and also in east direction. So simply we can write down, is asking us about vertical component and horizontal component. Vertical component simply is equal to V cosine of angle, means this angle, cosine of this angle. V in this case, this is equal to 75 and cosine of 30 degrees. Simply if we solve this one, this is equal to 64.9 meters per second. So this is our vertical component in this direction. We need to find out the horizontal component, that is equal to V sine of angle, sine of this angle. So simply we can write down this is 75 times sine of 30 degrees. In this case, our final answer will be 37.5 meters per second, or approximately we can say this is equal to 38 meters per second. So this is correct answer. For this question, a micrometer screw gauge is used to measure the diameter of a copper wire. We have two diagrams here, diagram 1, diagram 2. Diagram 1 is when the wire is inside the jaws of the micrometer. So this is shown in diagram 1, means with wire. When the wire is inside the jaws of micrometer, we can simply write down this is with wire. This is without wire, when the wire is removed and jaws of micrometer are closed. This is without wire, so simply we can write down this is diagram without wire, when wire is not inside the jaws of micrometer, without wire. And if you look at this one, the reading on this is equal to 14, means the circular scale reading is equal to 14. So this is 14. If you multiply this one with the least count of micrometer, that is equal to 0.01 mm. So this is equal to 0.14 mm, and this is zero error, but this is positive. This is zero error, but this is positive zero error because this reading is greater than actual. So we can say this is positive zero error. So as you can see here, this is positive zero error. This is 0.14 millimeter. I have already written here. We need to understand how to read this. In this case, you can see the linear scale reading that is equal to 2.5 and circular scale reading that is 9. If you multiply 9 with 0.01, again you will get this is 0.09. Now we need to add these two, so this is our final answer. This is the reading on this one. This is reading on micrometer, so we can write down reading on micrometer. This is reading on micrometer, but this is not the final answer and this is not the diameter of the wire. In order to find diameter of the wire, we need to subtract this one because this is positive zero error, so this is the reading higher than actual, so we have to subtract. And our final answer is this. So B is the final answer. If instrument has positive zero error, it simply means that the measured value is always greater than actual value. Or simply we can say the measured value minus actual value, that is equal to positive zero error. So simply we can say that will be equal to zero error. All the readings will be greater than by this amount. Zero error is an example of systematic error because all the readings will be greater than actual value if this is a positive zero error, and if it is negative zero error, all the values will be smaller than actual value. For this question, current is given, the mean value of the current with absolute uncertainty is given. Potential difference, its mean value and absolute uncertainty is given. We need to calculate the percentage uncertainty in the calculated resistance. Now, first of all, we need to understand how potential difference, current and resistance, they are linked together. They are simply linked together by Ohm's law. This is very simple, Ohm's law. V is equal to IR, so R is equal to V by I. Now you can see these two quantities are divided. So it simply means that we need to add the percentage uncertainties to calculate the percentage uncertainty in resistance. For that reason, we have divided absolute uncertainty by the mean value of potential difference plus absolute uncertainty in I divided by its mean value. Multiply by 100, then just simply solve this one, and this is the percentage uncertainty in resistance. For question 6, it is given there are 4 cars A, B, C and D. They move from rest in a straight line. Cars take the same time to accelerate to a velocity of 60 km per hour. The VT graph is shown in this figure. We need to find out which car reaches a velocity of 60 km per hour in the shortest time. That is the main thing. First thing, now we need to understand what is area under VT graph. Area under VT graph, so let me write down here. Area under VT graph, this is equal to displacement. So simply we can write down this is equal to displacement. As cars, they are moving in a straight line, so displacement and distance, they are equal. So we can also write down this is equal to distance. The next thing we need to understand, the shortest distance. Shortest distance simply means that the smallest area. The smallest area. Now simply we need to find out the car with the smallest area. Means the VT graph for a car which has the smallest area. So this curve, if you look at the D, this area is the smallest. So the answer is D. This question is about projectile motion. It is given to us that a cannon fires a cannonball with an initial speed v at an angle alpha to the horizontal. We need to find out the maximum height reached by the cannonball. This question is asking us about maximum height. So we need to consider vertical motion only. So we will consider vertical motion only. For this purpose, we will take upward as positive. Now, if we look at the initial speed, we can resolve into two components. So this is a horizontal component and this is vertical component. Vertical component is simply equal to V sine of alpha. And the second thing we need to understand, at the peak, v vertical means v final in vertical direction, that will be equal to 0. Now if we have these two, then we can write down the u means the initial speed, this is equal to v sine of alpha, and the v final means the final velocity at the peak, that is equal to 0. Now we also need to understand acceleration is equal to g, and direction of acceleration is always down, so it means it is negative because we have taken up is positive, so this one is negative. Next thing we need to find out the vertical displacement. Let's say this is s and this is equal to capital H, the maximum height. Now simply we need to use SWOT equation, so we can write down s is equal to v square minus u square divided by 2a. V is equal to 0, so simply we can write down this is 0 minus we have v sine of alpha square divided by 2g, but g is negative, so this is negative g. Now simply if we solve this one, we will get this is minus v square sine square alpha divided by minus 2g. So negative negative cancel, and our final answer is this one, and this is the maximum height reached by cannonball. So the answer is C. For question number 8, it is given that a ball strikes a horizontal surface with momentum p at an angle theta to the surface as it is shown in this figure. The ball rebounds with the same magnitude of the momentum at an angle theta to the surface. The ball is in contact with the surface for time t. We need to find out what is the magnitude of the average resultant force on the ball during the collision. So first of all, we need to understand how to calculate average resultant force. Average resultant force is equal to the change in momentum over time. But time is already given, that is equal to t, so we no need to worry about time, we no need to calculate. This is equal to t. We need to find out what is the change in momentum. So we need to find out p final minus p initial. Now let's say this is our p initial and this is p final. First of all, we will answer this question by resolving vectors into its component. Let's resolve initial momentum into its component. So if we resolve initial momentum into its component, you can resolve like this. So this vertical component is simply equal to p sine of theta, because this is opposite to the angle, so this is p sine theta. And with angle, this is p cosine theta. The same we need to repeat for this final momentum. So we can also resolve this one into its components. So this is horizontal component and this is vertical component. Horizontal component, again this is equal to p cosine theta, and vertical component, this is equal to p sine theta. We will check change in momentum in x direction, also change in momentum in y direction. First of all, let's try to find out change in momentum in x direction. We will take to the right as positive. So the delta p along x direction, this is simply equal to p cosine of theta, means the p final in x direction minus p initial in x direction. P final, this is p cosine of theta. P initial is also p cosine of theta. So final answer is 0. So there is no change in momentum along x direction. Let's try to find out change in momentum along y, means in y direction change in momentum. So simply we can write down delta p in y direction, this is equal to p in y direction final minus p in y direction initial. For that purpose, we need to take one direction positive because one momentum is down. This component down, that is up, but we will take up is positive. So this component is positive and this one will be negative. Simply we need to plug in values. So P final, simply we can write down this is P sine of theta, and P initial, this is minus P sine of theta. Now minus minus, if we multiply, plus, so this is P sine theta plus P sine theta. Simply this is equal to 2 P sine theta. So this is the change in momentum. So we can simply write down this is 2P sine of theta divided by T. So our final answer is D. Now we will answer this question using the different methods. In the last method, we have discussed how to answer this type of problem by resolving vector into component. In this method, we will study how to answer this type of problem by adding vectors. Here we have two vectors. Let's say this vector is P1 and this vector is P2. We need to find the change in momentum because we need to find out the force, the average resultant force. This is equal to delta P over T. T is the same because in question it is given time is equal to T, but we need to find out delta P. Delta P simply we can write down this is equal to P2 minus P1. We can also write down this one P2 plus minus P1. Now from here it simply means that we need to add two vectors P2 and minus P1, and that will be equal to delta P. Now simply we need to add these two vectors P2 and minus P1. Minus P1 simply means that this vector has the same magnitude as P1 but its direction is opposite. What exactly it means? It means that P1 and minus P1, they have the same magnitude. Their direction is opposite because P minus P1 is a negative vector of P1. So this is our minus P1. Simply we need to add these two vectors, means P2 and minus P1. First of all, let me draw P2. So we will draw one line equal to this vector magnitude P2. So this is our vector P2. We will take this vector from here and place here. So this is our P2. Now we will repeat the same process for minus P1. So this is our vector minus P1. We can also adjust. So this is minus P1. We will place here. So this is how you can add these two vectors together. So this is minus P1. Now we need to find out the resultant vector. Simply you need to add these two vectors together. So this is the resultant vector. This is our vector P2. So let me label first of all. This is P2 and this is minus P1. The magnitude of this one, this is equal to P, and the magnitude of this one, this is also equal to P. And this vector, let me draw arrows here. So this is P2 and this one is P1. And this is our vector delta P, means the difference between these two. So this is delta P. Now if you look at P1, P1 is making angle theta with horizontal. So this angle is theta. We can simply write down this is theta and this angle is also theta. Now we can divide this one into two parts, this triangle. So this side means this half of that from here to here. So this will be equal to delta P by 2. And this half, this will be equal to delta P by 2. If we look at sine of angle, sine of theta, this will be equal to delta P by 2 divided by P, means this one. From here we can find out delta P is equal to 2P sine of theta. So simply this is our delta P, this is equal to 2P sine of theta divided by T. And this is our answer. This is kind of typical question about Skydiver and terminal velocity. First of all, let's try to understand this question with the help of VT graph. So let me write here velocity on vertical axis and time on x-axis. So at the beginning, when the skydiver will jump, velocity of skydiver will increase like this. Finally it will reach a terminal velocity. So at this point we call first terminal velocity. Now if you look at this one, you can easily understand, velocity is increasing but the gradient is decreasing. It simply means that the acceleration of Skydiver is decreasing with time, and finally at this point acceleration is equal to 0, or simply we can say at this point mg is equal to a resistance, or we can say is equal to drag force. We can say simply is equal to drag. But for this question it is given to us opens his parachute. So when Skydiver will open his parachute, at this point velocity suddenly will decrease and again it will reach a terminal. Now we need to understand at this point why velocity decrease, because when this Skydiver is falling down and suddenly open this parachute, drag force increase dramatically. This one is the drag, so this will increase, but weight remains same. So now acceleration is upwards, but still Skydiver is falling down, velocity is still down. In this case Skydiver will slow down. Its direction is still downwards. So simply direction of velocity is still downwards, but magnitude of velocity decreases. That's the reason answer is A. For this question it is given a stationary firework explodes into 4 fragments, mean into 4 pieces, which travel in different directions in a horizontal plane. Now first of all, stationary is very important. From here we can understand initial momentum is equal to 0. So the final momentum also has to be equal to 0 because this is an isolated system. So simply we can say that in any direction change of momentum has to be equal to 0. So we can simply write down in any direction delta p has to be equal to 0. This is the main concept we need to answer this problem. Now if we look at all these fragments, the angle between these vectors is 90 degrees. You can see this angle is 90 degrees, this is also 90 degrees. So it means that vectors are perpendicular to each other. We no need to resolve into components, or simply you can treat, if you take this direction is x direction, so simply I can write down, let's say this direction is x, we can say this is y direction. So you can also write down like this. We need to find out the velocity of this fragment x. For this one it is given to us, we have the mass of this fragment, we have velocity. So simply we can say that 10g times 300 meters per second, this one has to be equal to 15g times, let's say, velocity v. From here v simply we can find out that will be equal to 200 meters per second. So our answer is A. Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper questions from March 2020 paper 1-2. In this lesson, we will discuss these questions in detail so you can have better understanding about these concepts. We will not only find the best possible option, we will also go through incorrect options. I will explain why those options are not correct. For question number 11, it is given to us a particle with mass moves in a horizontal straight line through a uniform electric field in a vacuum. So in a vacuum, it simply means that we can ignore air resistance. So this is simply telling us we can ignore air resistance, mean air resistance is equal to 0. It is also given to us that there is a significant gravitational effect on the motion of the particle. It means we cannot ignore gravity. We have to consider the effects of gravity in our calculations. Question is asking us what could be the direction of the electric field and the sign of the charge. So first thing we need to find out what is direction of electric field. This is one thing we need to find out. And the second thing we need to find out what is the sign of the charge. First of all, let's imagine that there is only one force acting on this particle. Let's say that force is gravity. If there is only gravity acting on this particle and gravity is always acting vertically downwards, then the motion of this particle, the path this particle will take, that will be parabolic path. Means particle will move like this. But we want this particle to move in a horizontal straight line. So it simply means that forces acting along vertical direction, those forces has to be balanced. One force we have, that is mg, that is acting down, but particle is moving in a uniform electric field. There must be another force acting on this particle. That force has to be electric force, and this one has to be equal to mg, but we understand electric force is equal to eq. So from here we can say that Fe has to be equal to mg if this particle is moving in a horizontal direction. Now let's try to look at these options and try to find out the answer. If you look at option D is telling us there is no charge on particles. If no charge, it means there is no electric force, so particle will follow this parabolic path. So this is not possible option. So this is incorrect option. So simply we can eliminate this option. We can eliminate this one. We left with three options. We look at all these options one by one. First of all, it is given to us electric field direction is down. So simply we can draw our electric field like this. So electric field is pointing down and the charge is negative. If the charge is negative, so the force on the charge here, let's say this is our negative charge. We can also say this side is positive. If you're not very clear, you can also say the positive and negative. So the force on this particle will be up, and this is direction of electric force on this particle. So this is possible option. So we can say this can be correct answer. Let's look at option B now. For option B, it is given to us electric field is still acting down, means direction of electric field is down. This is pointing downwards, and this is uniform electric field. But in this case, the sign of the charge is given. The sign of the charge is positive. If this is positive, so it will move in direction of electric field. So it simply means that it will experience electric force in downward direction. So this is not possible answer, because electric force has to be pointing upwards. So this is not possible option. For option C, direction of electric field is upwards and the sign of charge is negative. First of all, let's write down this is option C. For option C, direction of electric field is upwards, so this is our uniform electric field. We can draw like this, and the sign of charge here is given, that is negative. So this is our negative charge. We can also say this side, this plate, let's say it is between two plates, so this plate has to be positive and this plate has to be negative. Now negative charge is placed inside this uniform electric field. This will experience force in direction opposite to the electric field lines, means opposite to electric field direction. So it will experience force down. So this is also not possible option, because electric force has to be pointing upwards. Our answer is A for this question. For question number 12, it is given to us that there are two forces, two parallel forces, each of magnitude F, act on a rod of length 5d. Which diagram shows the positions of the two forces that will produce the largest torque on the rod? First of all, we need to understand what is torque. This is turning effect of a couple. So this is simply, first thing you need to understand, what is the torque? Torque is turning effect of a couple, that is torque. So this is the first thing you need to understand. Torque, simply we can write down, this is equal to the magnitude of one force times the perpendicular distance between two forces. Perpendicular distance between two forces. So this is how we define the torque. If you look at option A, in this case these two forces, they form a couple, because these two forces, the magnitude is the same. They're acting in different directions and they're not acting along the same line. In this case, if you need to find, the torque will be simply equal to Fd. So this is how you can find the torque of this couple. If you look at option B now, option B, if you look at these two forces, these are like parallel forces. like parallel forces. These are parallel forces, but these two forces, they do not form a couple. In this case, this rod will not rotate. It will not rotate because these two forces, they do not form a couple, and two like parallel forces do not produce torque. You can simply write down, do not produce torque. So this is the point you need to understand, because these are two like parallel forces, they do not form a couple and also they do not produce torque. So in this case, torque will be equal to 0. So simply you can say that tau, in this case, tau will be equal to 0. So simply we can write here. If you look at option C, for option C, again we have two forces and these are like parallel forces. Again, these are two like parallel forces. We can again write down, these are two like parallel forces. They do not form a couple and they will not produce a torque. Do not produce a torque because they do not form a couple and they're like parallel forces. They do not produce torque, or simply we can say torque in this case will be equal to 0. So for C, tau is equal to 0. Now if you look at option D, these two forces, they form a couple. They have the same magnitude, they're acting in different directions, they are not acting along the same line, and they are separated by this distance. This is the perpendicular distance between these two forces. If we need to find out the torque produced by this couple, and that is equal to magnitude of one force times the distance between two forces, perpendicular distance between two forces, that is equal to 2d in this case. So simply this is equal to 2fd. If you look at all these options now, we can find the best possible option. We simply need to compare A and D. So this torque is the largest. This is our best possible answer. For this question, it is given to us a mass of 30 kg is suspended from the end of a wire. So you can see this is the mass. So this is our mass and it is suspended at the end of a wire. This one is the wire. You can see this is the wire. It is also given to us there is a horizontal force F that is acting here. So this is horizontal force acting along horizontal. It is also given that this is in equilibrium. So equilibrium simply means that the resultant force acting on this mass is equal to 0. Resultant force in any direction. It means if you look at the forces acting along horizontal, they has to be equal to 0. And if you look at forces acting along vertical, they also has to be equal to 0. So it simply means that F net in x direction has to be equal to 0 and F net along vertical also has to be equal to 0. We are not talking about z, so if there is z, it also has to be equal to 0. So simply we can say along x and along y, resultant force has to be 0. Second way to understand equilibrium is that if we draw the vector diagram, so next thing we need to understand, if we draw the vector diagram for any object that is in equilibrium, then the forces must form a closed polygon. Means it can be triangle, it can be rectangle, polygon. They must form a closed polygon. We will use this vector addition method to answer this question. Let's try to draw the vector diagram. Before we draw the vector diagram, we need to find out the forces acting on this object. First force we can say the acting on this object, this is the mg, this is the gravity. The second force F, horizontal force, is given, and the third force is the tension in the string. So this is acting in along the string in this direction. Now we need to add all these forces. First of all, let's draw weight. This is gravity that is acting vertically down. The second, we have horizontal force that is acting along horizontal. The last one, this is the tension. So this is the tension force. So we can complete over this vector diagram. So we can also label, this is the mg and this is the force F, and this force is tension, this is T. We also need to understand this angle as it is given here. This angle is equal to 30 degrees. We can also label here. Now if we look at this angle, we can simply write down that tangent of 30 degrees that will be equal to the opposite side divided by adjacent side, that is mg. From here simply we can find out f, that will be equal to mg times tangent of 30 degrees. But we have value of mass, we can simply plug in value of mass, and g, this is 9.81, then we just need to multiply with tangent of 30 degrees. If we do this calculation, our answer will be 170 newtons. So the answer for this question is C. Let me explain to you this question using a different method. In this method, we will resolve forces into their components and we will find the value of horizontal force. For that purpose, we need to resolve tension into its component. If you look at tension, it has two components. It has one component that is acting vertically up, so this is one vertical component, and it has another horizontal component that is acting opposite to this horizontal force. This component means the vertical component. This is equal to t cosine of theta, or simply we can say this is equal to t cosine of 30 degrees, because this is with this angle. If we look at horizontal component, this is equal to t sine of 30 degrees, because this side is opposite to this angle, so this is t sine 30 degrees. Now we need to equate forces along x direction and along y. If you look at x direction, we have two forces. F is acting to the right, so this is acting to the right, and x means the x component, the horizontal component of tension, this is acting to the left, so this is simply t sine of 30 degrees. These two has to be equal because this mass is in equilibrium. This is acting to the left. These two forces are equal. Now if you look at forces acting along y direction, we can simply write down, we have this force means the gravity that is acting vertically down, but we have a component of tension that is acting vertically up. So from here simply we can say mg, this is acting vertically down, this has to be equal to the component of tension that is acting vertically up. Now simply we can also draw like this here. This is F and we have component of tension that is acting this way, and this is t sine of 30 degrees. For this one we have mg that is acting down and component of tension that is acting vertically up, and these two forces they are equal. This is t cosine of 30 degrees. Let's say this is equation 1, let's say this is second. Now simply if we divide 1 by 2, then we can write down F over mg, this is t sine of 30 degrees divided by t cosine of 30 degrees. tt we can cancel, then we simply left with F over mg, or simply we can say this is mg tangent of 30 degrees. Same equation we have, we need to simply plug in values. G is 9.81, this is tangent of 30 degrees. If we solve this, we will get value of F that is equal to 170 newtons, and this is our final answer. That's correct option. C is correct option. In today's class, we will discuss a typical problem on stress strain from Cambridge AS Physics, and this question is from June 2020. For this question, it is given to us that a simplified model of a building with 4 identical heavy floors. Identical heavy floors simply means that each floor has the same weight. So we can write down here each floor has the same weight. And let's say the weight of each floor is equal to W. We can also write here W means this is the weight of each floor. Next, it is given to us that the spacing of the bottom floor means this floor. This is our bottom floor. Spacing of this bottom floor from the ground is twice that of the spacing between the floors. Means this spacing between the floors, this is the spacing between floors. Let's say this spacing is equal to x, and the spacing between the bottom floor and the ground, this is twice, so it simply means this is equal to 2x. Next, it is given to us that between each floor are equal numbers of vertical steel supporting rods of negligible mass as compared with the floors. Means the mass of the rods we can consider is negligible, or we can simply say is very small as compared with the mass of each floor. Next, it is given to us that the rods are of different diameters, but stress in each rod is the same. Very important point, stress is same. So I will write down here stress in each rod, this is same, so stress is same. Question is asking us to find the ratio between diameter of bottom rods and diameter of top rods, but it is given to us that there are equal numbers of vertical steel supporting rods, meaning there are equal number of rods. Let's say the diameter of bottom rods, these rods, the diameter is equal to dB, and let's say the diameter of top rods is equal to dt. Now in question it is given to us that stress in each rod is the same. So this is the main concept we need to answer this problem. First of all, let's try to understand what is stress. Stress simply is equal to force over cross-sectional area. Now let's say we have one rod, for example, this is hanging here, this is the rod, and cross-sectional area of this one, let's say, is A, and if I apply force F on this rod, then stress simply is equal to F over A. But for this question it is given to us that the stress in the top rods and stress in the bottom rods is the same, so simply we can write down here stress in the top rods and bottom rods is the same. So we can write down the formula for top rods and for bottom rods. So for the top rods, stress is equal to F over A, and for the bottom rods, stress is also equal to F over A. But the force here, this is the force acting on the top rod, and this is the force acting on the bottom rod, and this will be the cross-sectional area of top rods, and this will be the cross-sectional area of bottom rods. Now if you look at the top rod, this top rod is only supporting one floor, and the weight of one floor is equal to W. So it simply means that the force acting on top rods is equal to W. So I can simply write down this is W. And cross-sectional area of top rods we can also write down, this is pi by 4 dt square. We can write down dt square. And if we look at the bottom rod is supporting 4 times W. I mean this is supporting 4 floors, 1, 2, 3 and 4 floors, and the weight of each floor is W. So we can write down here 4 times W. And the cross-sectional area we can also write down in terms of diameter. So we can say d by pi by 4 dB square. That's all what you need to do. Now simply we need to cancel and we can find our final answer. Now as you can see here, W is common here, so we can cancel. Pi by 4 is common, we can also cancel. Now if we simplify this, we have got dt square, means simply let me write down dB square is equal to 4 times of dt square. So this is dt square, but the question is asking us the ratio between dB by dt, so we can write down here, so this is dB by dt, dB by dt, and this is equal to square root of 4. So our final answer is 2. So the ratio between diameter of bottom rods and top rods, this is equal to 2. So this is our final answer. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's class, we will discuss kinematics of hot air balloon which is moving vertically upwards with constant speed. And we will answer past paper questions using different methods so you can have clear understanding about this type of problems on kinematics. For this question, it is given to us that a hot air balloon is moving vertically upwards with a constant speed of 3 meters per second. A sandbag is dropped from the balloon. It takes 5 seconds for the sandbag to fall to the ground. And question is asking us, we need to find the height of the balloon when the sandbag was released from the balloon. Let's try to sketch this problem, because the best way to answer any questions in physics is to sketch. When we sketch any problem, we can visualize. When we can visualize a problem, then easily we can answer. Let's try to sketch this problem first. As you can see here, I have already drawn balloon here. So let me draw sandbag as well. So this is the sandbag. You can even write down here. So this is the sandbag. This is attached with balloon. The balloon is moving vertically upwards with a speed of 3 meters per second. So anything which is part of the balloon that also have the same speed. So in this case, sandbag also have the same speed, that is 3 meters per second. And sandbag is also moving vertically upwards with the balloon. That is very important point. For this question, we need to find the height of the balloon when the sandbag is released from the balloon. So it simply means that we need to find this height. In order to find this height, we need to study the motion of sandbag. So let me redraw sandbag. So this is our sandbag and this is the height what we need to find out. So let me label again. This height we need to find out. This is the height we need to find out. Now, initial speed of the sandbag, as we have already discussed, this is equal to 3 meters per second. And this sandbag will continue moving with this speed upwards, but this speed will decrease because there is a force of gravity that is acting on this sandbag. And finally, the speed of sandbag at certain height, that will be equal to 0. And then the sandbag will start falling downwards. So it will move towards ground and finally it will hit the ground. So let's say it hit the ground at this point. And the total time taken when it is released from the balloon to go up and to reach the ground, that is also given. And that time is 5 seconds, 5.00 seconds. As this sandbag, this is in free fall, we can also write down this is in free fall. It simply means that only force acting on this one is gravity. So the acceleration of this sandbag, that is equal to 9.81 meters per second, and that acceleration is down because gravity is pulling this sandbag downwards. And initial speed of this sandbag, that is also given, that is equal to 3 meters per second. We can also write down. And what we need to find out now is we simply need to find out the vertical displacement, means from here to here. This is the vertical displacement we have to find out. And that vertical displacement, this is equal to height. So this is height. Now we can also write down height is equal to vertical displacement of sandbag from the ground. So this is what we need to find. And the speed, initial speed is upwards. We can also use arrow to show that the speed is upwards. Now simply we need to use kinematic equations to calculate final value of vertical displacement. Before we use kinematic equations, we need to take one direction as positive, as in this case we are only talking about vertical motion, so we can take up positive or we can take downward positive. In this case we are assuming that downward direction is positive. As the downward is positive, so it means the acceleration is positive, and initial velocity, this is negative because its direction is vertically upwards. Now simply we need to plug in these values and we can find our final answer. We can simply use s is equal to ut plus 1/2 a t square, because we have u, value of u is given, t is given, and a is given. T is the time taken from point of release for this sandbag to go up and then come back to the ground, means the total time taken is given. So that's the reason we can calculate vertical displacement from here to here. U is given, we can just plug in value of u, we can just plug in value of a is 9.81 and the time is 5. And our final answer will be 107.625 meters, or we can simply say this is about 108 meters. So our final answer for this question is B. As we have already discussed motion of this sandbag, now we will use velocity time graph to find the vertical displacement. We have discussed that its initial speed, this is equal to 3 meters per second, so we can write down here, and the speed of the sandbag at the maximum height, that will be equal to 0 meter per second, we can write down at this point. Now first of all, let's try to find out the time taken by the sandbag from this point of release to the maximum height. So that time we can simply calculate by v is equal to u plus at. In this case, v is equal to 0 and the u, if we take upward direction as positive, let's say upward is positive, so the u, this one will be positive, but acceleration due to gravity, this will be negative because acceleration is downward, so this will be negative. Now we can simply plug in values here and we can find out value of t, and a in this case is negative 9.81 times time. So the value of t, we can find out the time taken from point of release to maximum height. That time taken will be equal to 0.31 seconds. Now we understand at this point velocity is equal to 0. If we need to find out the velocity when it hit the ground, let's say that velocity is v1. Now the total time taken is given, that is 5 seconds. So the time taken from this point to this point, let's say that time taken is t1, and t1 will be equal to 5.00 minus 0.31. So simply we can say that is equal to 4.69 seconds. Now at this point we have the value of the v, final v we have to find out, and we have the time taken. So again we can use v is equal to u plus at. U plus at. In this case we will take downward as positive. So final v1, this is we need to find out. Initial value of u means this v, this is simply is equal to u, so we can write this is equal to 0, and value of a is given, that is 9.81 because this is in free fall, and the time taken we have, that is 4.69 seconds. So if we plug in values, we can find out the value of v1. And v1 in this case is equal to 46.0 meters per second. We can write down here v is equal to 46.0 meters per second. So this is, now that's all we have done all. Simply we need to sketch velocity time graph now. Now let's try to sketch velocity time graph. In order to sketch velocity time graph, we need value of u, means we need value of initial velocity, we will need value of t, we will also need value of v1, and also we will need value of total time taken. In this case, total time taken for this sandbag to go from point of release to reach maximum height and to come back to the ground, this is equal to 5.00 seconds. Now let's sketch v velocity on y-axis. So this is velocity on y-axis and this is in meters per second, and time is on x-axis and the unit of time is seconds. But one thing we need to understand is that, as in this case our acceleration is constant and direction of acceleration is downwards, so it means that the gradient of velocity time graph, this has to be constant. We also need to consider one direction as positive, let's say downward as positive, because our vertical displacement is downwards from point of release, so we will take downward as positive, so we will get positive answer for vertical displacement. Now simply we need to sketch. As you can see in this case, we have initial value of the velocity. Initial value of velocity has to be negative. Why it has to be negative? Because we have taken down as positive. That initial value of velocity means the velocity is vertically upwards. This is upwards. So initial velocity is negative because direction is opposite. And then after time t means at this time 0.31 second, the v is equal to 0. I mean this is the peak, so we can label this one, this is the peak, means this point. And the value of v1 we have at this point, and value of v1 we can also write down here. This is equal to 46.0 meters per second. And the time, the total time at this point, this is equal to 5.00 second. Now if we look at this area, this one, area between v and t, this is displacement from this point to this point. This is the displacement, and this displacement is negative because we took down as positive, so we can calculate this area. So area of this triangle, simply we can find out, this is 1 by 2 and the velocity multiplied by time. Time is the base, so final answer in this case will be equal to 0.465 meters. But this is negative, this is negative, and this is the area. I mean this displacement is from the peak to the ground, so this is from peak to the ground. We can also say that this area is equal to s1, and let's say this is equal to s2. And so we can calculate area of this triangle, and that is equal to S2. So S2 in this case is equal to 1 by 2, and this will be 5 minus 0.31, means this is 5 and this point is 0.31. Height of this triangle, this is 46. So our final answer will be 107.89 meters. And this is positive, so we can write this displacement is positive. So this is positive if we take from here, so this is positive. What we need to find out, we need to find the displacement from this point to this point, so we can also say that is equal to s. So s simply in this case is equal to s2 minus s1. So we can write down 107.89 minus 0.465 meters, and our answer will be in this case 107.425, or we can simply say it is very close to 108. We can write down about 108 meter, and this is our final answer. For this question, it is given to us that a student is investigating the mechanical properties of a metal and he has plotted a graph of stress against strain. The student also repeats the experiment with a wire that is made from the same metal, but its dimensions are different, its length is double and its diameter is half. We need to simply find out which graph he will obtain from these given 4 options. Actually, this question is simply based on Young's modulus. Let's try to understand what exactly is Young's modulus. Young's modulus is also called modulus of elasticity. Modulus of elasticity. Elasticity we need to understand because this is also a very important concept. It is called modulus of elasticity because elasticity is the ability of a material to regain its shape. If a material has higher ability to regain its shape, its Young modulus will be higher. If it has low ability to regain its shape, its Young's modulus will be lower. For example, Young's modulus of steel is higher than Young's modulus of rubber. Now let's try to understand what is the relationship between Young's modulus and stress and strain. Young's modulus is the ratio between stress and strain. So simply we can say stress divided by strain. So you can use Y or you can use E. Now, we also need to understand that Young's modulus is property of material. Like the resistivity, resistivity is a property of material that does not depend on dimensions. And same Young's modulus is also property of material. So first thing we need to understand is this is property of material. It depends on type of material but does not depend on dimensions. We will go to that point later. It depends on type of material. It depends on type of material. It simply means that let's say we have one wire, this is made of copper, and let's say we have another wire and the second wire also have the same dimensions, but this wire is made of steel. So the Young's modulus of copper wire in this case will not be equal to Young's modulus of steel because these are two different materials. And the second thing we need to understand about Young's modulus is that it is independent of dimensions. So it is independent of dimensions. What exactly it means by independent of dimensions? It simply means that let's say we have one wire and this wire is made of copper. And we have another wire and this wire is also made of copper. But for this wire this is L and for this wire L1 let's say, and this is equal to 2 times of L, and let's say the diameter of this wire this is D and the diameter of the second wire this is D by 2. Now these two wires, they are made of the same material. Even their dimensions are different, but Young's modulus for these two wires is the same because they are made of the same material. So it simply means that Young's modulus does not depend on dimensions. So it is property of material. If temperature is the same, Young's modulus is the same for a wire if the wire is made of same material. So if Young's modulus is the same, so we can also say that for the same stress, for example, if Young's modulus is the same and at the same stress, there must be same strain. So strain also has to be same. So from here we can simply conclude that if the wire is the same, so the graph we will obtain that also has to be the same. Graph has to be identical. Even the dimensions of the wire are different because the student is using an other wire that has different dimensions but is made of same metal, made of same material. So Young's modulus is the same. For any value of stress in the wire, strain also has to be the same because Young's modulus is property of material. If the wire is same, Young's modulus is also same. This is our graph for first wire. You can see this is the graph for first wire. So simply we can say this is for first wire. This has to be the graph for second wire because these two graphs has to be identical. So this is graph for second wire. Graphs are identical. Why? Because it is made of same material. So our answer for this question is B. First of all, let's try to understand what is given to us. If we read this question carefully, it is given to us that there is a rock R of mass this much. The mass is given to us and is at a large distance from a star S. And the rock is traveling at the speed of the rock is given, and mass of star is also given to us. And rock reverses its direction of motion and has the same speed as initially at a large distance gain. If we look at this diagram, it is also given to us at this point we have this rock. It is at a large distance from this star. So this S for star, and the speed of rock is given, mass of rock is given, and mass of star is given to us. And the speed of rock is also given here. So at this point rock is moving to the right and here rock is moving to the left. Now what we need to find out, simply we need to find out which statement is correct. We have 4 options, we have to choose the right one. Now in this case, if we study this system carefully, one thing we can conclude is that this is isolated system, as there is no any other object in its surroundings. So we can treat this system as an isolated system. And also the second thing what we need to understand is that in this system these two bodies are interacting with each other. So this is a special kind of collision. So we can also write down this is a special kind of collision in which two bodies are interacting with each other. So this is second thing we need to understand. Now as we understand now, it is a kind of collision in which bodies are interacting with each other and they're exerting force on each other, even there is no any physical contact between them. So we can use law of conservation of momentum. So let me explain to you first of all few important points, and then we will use those points and we will answer this question. Let's say we have two objects. Let's say we have object X and we have another object. This is object Y, and these two objects, they collide with each other. So the Y will exert force on X. We will say this is force on X by Y, force on X by Y, and there will be force on Y by X, force on Y by X. So I will simply say this force Fx, and this force I will simply say this is Fy. Now these two forces, the magnitude will be same, even the direction is opposite. We can simply say Fx is equal to Fy, the same magnitude. They have same magnitude, even direction of force on these two objects is different. Now second thing we need to understand, the time of impact means the time force Fx is acting on X is the same as the time for force Fy acting on object Y. So time of impact is also same. Now if I write like this, Fx Tx, this also will be same as Fy and Ty, and Fx Tx, if we remember, so the product of force and time of impact, that is called impulse. So we can say impulse is also the same, the magnitude. So you have to be very clear here, we are simply talking about magnitude. So magnitude of impulse on X and magnitude of impulse on Y is the same, but direction is different, direction is opposite, but magnitude is the same. Change in momentum, so the change in momentum for X and change in momentum for Y is also the same, magnitude is the same. Even the change is in opposite direction, but magnitude is the same. So this is all what we need to understand. If you're very clear about this one, this question is very simple to answer. Now first of all, let's look at option A now. What option A is telling us? Option A is simply telling us the change in momentum of S is in direction of arrow X. Means the change in momentum for the star is to the left. So let me redraw here. So this one is over star. We can say this is S. At this point, the rock is at this point. So this is R. So the rock is at this point. Now between these two objects there is gravitational force, so the rock is pulled to the left and the star is pulled to the right. As the resultant force on star is to the right, so the change in momentum also has to be to the right. So the delta P, the change in momentum for this star, it has to be to the right. But option A is telling us it is to the left. So this is not right option. Now let's move on to B now. The change in the velocity of X is approximately 20 meters per second. So this is based on calculation. We will do calculation later. Let's move on to next one. Option C is telling us the magnitude of the change of momentum of R. Magnitude of change of momentum of R is 10 to 3 times greater. No, that's wrong. This is not right, because we have discussed the change in momentum in magnitude is the same for two interacting objects. So this is also not our answer. Momentum of R does not change. But momentum of R is changing because momentum is a vector quantity. So even speed is the same, but velocity is changing. So momentum is changing. So this is also not right answer. So our answer is B. Let's do calculations and find our answer. We have already discussed that the magnitude of change in momentum for rock and also the magnitude of change in momentum for star, they are the same. Now simply we need to calculate change in momentum. Now first of all, let's try to find out change in momentum for rock. As you can see here, at this point the rock is moving to the right and here the rock is moving to the left. Now we need to find out change in momentum. As momentum is a vector quantity, so we need to decide one direction as positive. So in this case, let's say to the left is positive. If we take to the left is positive, we can also then this velocity will be negative and this velocity will be positive. Now we need to write down the change in momentum, so we can say this will be V minus U, and for the star we will simply write down the mass of star and we will just simply write down delta V, because we need to find the change in velocity. So this is our change in velocity. This is what we need to find out. Now in this case the mass of the rock is given, so we can just plug in values. Mass of the rock is 1.0 times 10 to 27 kgs, and the V in this case, this is 1.0 times 10 to 4, this is plus, minus, and as this initial velocity is negative now because we took to the left positive, so we will plug in here. This is minus, so this is minus 1.0 times 10 to 4, and here we have mass of star, that is 1.0 times 10 to 30 multiplied by delta V. Now you can see here, if we little simplify this one, so we will get this is 1.0 times 10 to 27, and here we have 1.0 times 10 to 4 plus 1.0 times 10 to 4, and this is equal to 1.0 times 10 to 30 times delta V. So from here, if we just plug in these values in our calculator, we will be able to get delta V, that is 20 meters per second. So this is our correct option.